Hello and welcome back to the lab. Today on the bench we have a Hewlett-Packard 6024A DC power supply. We have a 200 watt output and it does 0 to 60 volts at 0 to 10 amps. Not at the same time though, as that would be 600 watts. So we get a mix of 10 amps. To get 200 watts it would be 20 volts. Or up to 60 volts at less than 10 amps up to 200 watts. Decently stout power supply, kind of like it. We do have an unregulated output, but only when that light's lit. Does have current limit. That feels a little strange. Does have voltage limit, which will be good. And on-off, and that's about it. Overvolts protection, which does have a adjustment. It will probably crowbar. It'll either act one of two ways on a power supply. It'll crowbar out if you hit the overvoltage, or it'll just limit it at the voltage. I'm not sure which one this does yet. I expected it to be a lot heavier than it is. Usually power supplies, especially linear ones, are quite stout because they have a big transformer in them. So I am actually thinking this might be a switching power supply, which would explain why we're getting 0 to 60 volts or 10 amps in the weight, because it is fairly light. Just physically, it's fairly light. We do have a jammed power switch, so we'll have to address this before we put power to it, plug it in, and see what else is going on. So let me get the top cover off, and we'll take a look inside. I haven't even turned this on yet. Don't know what it's going to do, how it's going to function. It could be brain dead inside. It could be fully functional other than the power switch. I highly doubt it. It's got a kind of rough front. Going to need some cleaning. But after some cleaning, I think it might be a good bench supply to add to the stack of supplies. And see what we got going on. I do have a use for some just stout beater supplies. I want to say beater supplies in the lab, but just supplies that I abuse. We'll put it that way. The Rigel, especially when you turn it off, if you're charging a battery with it, if you plug a battery or a voltage source up to the output when the output is off, you'll actually blow the output. It does not have any reverse current protection in it, and it'll fry the output on this. Dave had a video on that. I've actually had to send this particular unit out for repair because that happened. If you hook a battery up to it when the output's on, everything's fine. It works just as you'd expect it would. It would charge a battery. However, if you have the output off, hook a battery up to it, you smoke the output. Some supplies like this, and also this guy right here, which is exceedingly heavy compared to this. Much smaller, but much heavier. This is a linear supply, 0 to 30 volts, 0 to 5 amps. This thing will drive a dead short. I can short these two terminals and it'll sit there all day and be happy. I have heard a few reports of a supply this style having some problems at an extremely high current setting, essentially 30 volts, 5 amps into a dead short. They tend to thermal overload a little bit, so don't do that for too long. But this is really my charging battery super abuse power supply. When I'm not sure what the state of something is, it gets plugged into this guy. It has taken so much abuse, and it hasn't had a single problem. For the price, this thing was great, and I use it for charging battery packs, things like that, all kinds of stuff. The problem is this 30 volts, at least for me, in what I'm working on, because I work on UPS battery kits and a couple of other things, 40, 60, 48, 60, 72 volts, depending on the battery chemistry and the number of batteries. That's some of where I need a higher voltage. I don't need a lot of current because I can just let the batteries charge for a while, and charging them slowly is not going to hurt anything. But 30 volts, most of the battery kits that I work on are above the rating for this, so we need something a little bigger. That's also what I use the 1010T, the transistorized power supply over there, and that's up to 100 volts. Still looking for a tube-based or a high voltage for doing some for doing some tube work power supply, so keeping my feelers out for one of those. But in the meantime, let's get this HP open. We shall do this in real time with the power toys. Pop these screws out. Nice and short, no problems. As long as I don't strip that one out. Sometimes you got to be careful with the power tools. But the lid's off. Let's see if we have a unit or a box of rocks. Well, we have parts, so that's good. Yes, we have a switching power supply. Okay. So this is going to be our switching transformer right here. These caps are probably going to be okay. These smaller ones we'll probably want to take a look at and replace. My guess is these are my output transistors, and this is probably my switching element, because this has a monster diode on it. Where does that go? So I would imagine this RCA is probably our switching device. Maybe half-wave rectification. This board is on an edge connector, so this board will come out pretty easy. Fuse, voltage selector, transformer of some sort, probably low voltage control circuitry, because I see some diodes. Here's a full wave rectifier out of discrete parts. Here are two more rectifiers with some smoothing caps. We have a REFA capacitor down here, which is a replace if found always, so that's going to get addressed. Probably leave these big cans in. These are probably going to be fine, but we'll update the little ones. So I noticed something. Let me take you to the front panel. So if we take a look at the front panel, we have the voltage potentiometer and we have the current potentiometer, and this is bent. So let's take a look at this. Well, I think we found maybe why it's on my bench. This pot is moving significantly. So the component that's behind here is busted off the board for sure. Now, the problem is, I think that might be why it wandered into my lab, is I have to extract this bottom board to fix that. Because this cover, yeah, there is no, there might be. This bottom panel might come off. Let me pop some of these screws out, see what happens. Okay, the screws are out and nothing fell out, so all right, we do get lucky. Okay, don't have to tear the whole thing apart. May have to dig a little deeper to get at the potentiometer under there. However, I do believe, oh, we have friends. There's a dead fly. Yeah, I can get to that REFA cap, I think. So I can at least get that REFA cap swapped out. So assembly-wise, I think if I unbolt the front panel, it looks like the board's going to slide, the sides will slide off that way. So let's see what happens if we can't extract this a little further. Holy cow, did that take more work than it needed to be. Here's our busted pot, which we're going to need to replace. But we have electrical connections on the meters that come in here that had to be snaked out. Had to take this trim ring off, the two knobs from the pots. Good news is the banana jacks got to stay. This board actually stays in because the connector here just unplugs. This ring does have to come off, but you have to be careful when it comes off because you'll pull the trim off the sides. And then there's screws hiding underneath this trim on each side that also have to come out. You kind of don't want to disassemble the case, and some of this stuff is an absolute bear to get out because it's actually put together with red Loctite. So be very careful, and the screws are going to take far more torque than you'd expect to pop them out. I have to get this switch greased. This switch is definitely having some problems. But let's take a look at this pot here real quick. Well, we're going to need to source a new potentiometer. I got the old one off. I only had to unsolder 2 pins, which is quite disturbing since I should have had to unsolder 5. This is a weird 5-pin part, but the pins are completely fractured off here, 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 and here. Board looks okay. Board doesn't look cracked or anything like that. So, and actually these 2 pins are tied together, so it's just a variable resistor from this point to this point. And it looked like shielding and grounding over here. So we'll clean out some of this fuzz right here. And I will work on sourcing another potentiometer to go in there. It is a 10-turn pot. It's a 2.7K, most likely a linear taper. But we'll see if we can get a part number, get one sourced in. I'm expecting about $10 or so for the pot. But got to at least get this one fixed first before we do much more digging. Okay, some new parts are in, but before we get started, I want to preface this by saying this is way more aggressive at a restoration and repair than I'd like to be. I like using, especially for mechanical parts, I like using original equipment when I can. The problem here was some of the parts had aged out completely, and some of the parts were also unavailable. We've got some issues. So this is a Borns 10-turn precision potentiometer, and all 3 lugs are sheared off on this one. These are just stabilization lugs, so that doesn't work anymore. And it turns out I can't even buy that value anymore. So this is a 2.7K 10-turn pot. I was only able to buy a 2.5K pot. So with the way this circuit works, I should have current control, again, because I did not have current control with this, but we're either going to miss some on the top or bottom. So it's not going to go all the way to 10 amps because it's about 200 ohms short. Now, I might be able to calibrate that out. I might not. I'm not 100% sure yet, but that is something I know going in. So we'll see. It either isn't going to shut off correctly, or we're not going to get a full 10 amps out of it. It'll be like 9.8 or something like that. So physical alterations. The pinouts were different on this, so it won't solder to the board, so I had to move the control to the front panel. That required routing out some of this PCB and also relocating this ground trace for the LEDs. The power switch completely falling apart. I got this switch off, tried to clean it, did everything, used all the normal tricks. The front end of this is cracking apart, and also the push button that was around it was literally just falling apart with age. The plastic was completely dead. So we needed to do something there. I'm not 100% sure I like the black look yet. We may switch this out to silver. Not 100% sure, but we're going to run with this for now. I'm also thinking about maybe turning it 90 degrees. Right now it mechanically fits. I did have to cut some of the board to make it fit, but it's just the power switch, so that's going to be all right. Again, way more aggressive than I like to be in these repairs and restorations, but I do want this power supply to function again. Right now, off and on are actually correct. This will be on, this will be off, so that works. I'm not sure if I like it right and left or if I should put it on up and down. Not 100% sure yet. We'll see how much that annoys me going forward. I might dive back into this and rotate this 90 degrees and make it fit. I do have a clearance issue if I rotate it 90 degrees on this PCB, and so we'll have to figure that out at that time. I also don't need 3 lugs on here. I only need 2. I do need 2 because positive and negative is, hot and neutral are switched on this particular unit. So when it's disconnected, it's truly disconnected, and we'll get that run in here in a second. So what happens is I have fork terminals coming off the back end power connector. They're going to go to the center. Because on is this way, these are going to be my hot and neutral ports. They will clear the side of the chassis, so I don't need to worry about those. But those are going to run down to the board, and I'm going to make a pigtail with appropriately insulated wire to come off of here with forks and then go down into the power pins of the board where they will just solder in and be permanent. And that's how we got the front panel hooked back up. So let me get this all put back together and we'll turn it on and see if we get smoke or if we actually have a power supply with a brain. Okay, we have added our pigtails for the power switch. I did leave it at line because this is line voltage. This isn't electronics voltages. I left the color code the same. Black will be hot, white will be neutral. That is the color code in my jurisdiction, which is why it's not red and black. So one thing to note, if you ever take apart a, at least a North American outlet, is black is the hot side in wall voltage or wall installations. Black is typically the negative in electronics components. So be very careful opening up wall outlets, and don't do it unless you have training and feel comfortable. And also check the color codes because they are quite different. Okay, I have the power supply hooked up to my load, and we're ready to give it a power on test. Let's see if the modifications will actually bring it back or not. See if everything's working before we put everything all back together. Go ahead and kick it on. No smoke. Fan turns on, and we have a voltage limit. No voltage on the display, and no current, but I don't have the load on. Current's all the way up. Voltage is somewhere. If I take a look at the load, the voltage is saying 5 volts. But I don't know why I don't have any deflection on the meter. So let's give it a check. See if there's any voltage across the meter. I'm guessing these are 1 milliamp full scale meters. So let's see what we have for voltage across the meter. Oh, we have 5.7 volts across the meter. So that meter may be toast. Let's check the current meter here real fast. Current meter says we have about 61 ohms across it, so 61 ohms, probably 1 milliamp full scale. Let's turn the load on, see if we get some deflection on the meter. I'm asking the load for 10 amps because that's what this power supply can deliver. And it's outputting 10 amps, so we actually have current control, which we did not before. So something has gone sideways on my control board and has grenaded this meter. I don't know if that happened before it ended up in the lab or after, but that one's going to be a tricky part to find. Let's see if we have any voltage output. We should. Yeah, 5 volts out. So that agrees with the load. So the power supply is mostly there. At this point, there'll be an error in the control board, and I'm pretty sure we can just triple check this here real quick. Turn this off, kick this over to 2-wire mode. $70K ohms. Yeah, that meter movement has been blown wide open. So this one was kind of a mess. So next step would be possibly redesigning this meter, maybe getting a digital version to pop in the front panel. To continue moving forward on this, we'll see what we can do. I'll think around how deep we want to get into this one. We're already pretty deep into this particular unit. I've rebuilt most of it. All my modifications worked all right. Just the voltmeter was dead, so that's no good. To see if my control board was working, and it was just my meter that was kind of stupid, I hooked up the load across the meter, and I asked the load for one constant current of 0.001 enter. 1 milliamp full scale, and we have a voltage across, which is what we'd expect. So that's the drive current for the meter. So to see if the control board is what's busted or if the meter was just came broken. We kick this up to 2 milliamps full scale, or 2 milliamps, which would be twice what the meter current was rated for, but the voltage falls to absolutely nothing. So the current monitoring to keep the meter from blowing up is working. That meter is just open and dead. Also, to prove that, if we go back to 1 milliamp full scale, or 1 milliamp across the meter, we get our voltage back. So the math does work out. Those are 1 milliamp full scale meters, but unfortunately, we have one that's dead. All right, so where are we at with this thing? Well, after a pretty stout rebuild, we have a functioning power supply. We do have one dead meter, one good meter, and now I got to search around for some spare parts. Finding this meter is going to be kind of tricky. But yeah, all in all, the supply works. Everything's good. So rebuild 99% successful on this one. Not good enough to throw it on the bench yet, or throw it in the lab to be used, but good enough to think about finding what's next for this particular power supply. So if you like what's going on the bench and you want to see more, hit the subscribe button and hang around. If you'd like additional content, check out the Patreon page. They've got early access to content that will eventually come out to YouTube, but they're currently running ahead. A huge thank you to all the patrons that do support the channel. Your help is greatly appreciated here in the lab, and your assistance helps keep the lights on. And also videos coming up to YouTube. So, as always, click all the YouTube buttons, subscribe, like, bell, and let me know how we did in the comments. I read all the comments on all the videos, and I see everyone in the comment section in between video releases. As always, more is on the way, and I'll see everybody in the next video.